Hello everyone, welcome to the first episode of Mainframe Modernization with AWS. I am Sunil Divela, Senior Mainframe Migration Solutions Architect based out of New York. In this episode, we are going to see what other customers are typically doing to migrate their mainframe workloads onto AWS and also dive deep into one of the short-term migration called replatforming to AWS. So based on various mainframe migrations happened on AWS, we had grouped all those projects into three different categories: augmentation patterns, short-term migration patterns, and long-term migration patterns. Short-term migration patterns are the patterns which helps customers to migrate their mainframe workloads to AWS within 1 to 2 years time frame and shut down their mainframe or a specific workload of the mainframe. So in short-term migration patterns, more often we see these three patterns being followed by our customers: middleware emulation, automated code refactoring, and modern middleware replatforming. Middleware emulation replaces the mainframe middleware APIs and operating system APIs, replaced with an emulation software that's being provided by emulation manufacturers. It's a short-term migration pattern, and it also rapidly helps you to exit off the mainframe as long as your legacy technology stack is supported by the emulation software. Basically, in this pattern, customers put in their entire legacy inventory or their entire legacy assets on top of an emulator, compile all the programs, generate the binaries, and run the workloads on AWS. Automated code refactoring transforms your existing legacy technology stacks to modern technology stacks such as Java, .NET, Python, and few more. This is 100% automation pattern where there is no manual involvement required. Coming to modern middleware replatforming, suppose in case if customers are running any kind of modern technologies on mainframes such as Java, C, C++, or PHP, so those kind of workloads can seamlessly be migrated onto AWS and run as a cloud native applications. In case if customers do not want to short-term migration patterns, any of these patterns, and they can look at long-term migration patterns, or they are looking at long-term migration patterns. In this area, we have two major patterns. One is rewrite, the other one is replace. Sometimes we can even call the rewrite as refactor and re-engineer, or like a manual rewrite. In this pattern, customers build their entire applications from the ground zero using modern technologies and modern architectures. So, for example, breaking the large mainframe monolith or megalith to microservice or nanoservice based architectures, or leveraging some advanced concepts like event-driven architectures, data-driven architectures, or even sometimes customers reimagine their business by transforming their business functions to digital enabled. For example, like taking some of the batch functions and transform them to real time. So that way they can be more agile, they can eliminate the technical debt, their business functions can be digitally enabled, and also they can innovate faster. And coming to the replace, this also can be called as a COTS deployment or a package installation. So this is pretty much followed by the customers in case if they already have a package software running on the mainframe, if they want to have similar kind of package software on AWS environment, they choose this approach. The long-term migration patterns are going to take anywhere between 2 to 5 years time frames, and even sometimes it's going to take longer than 5 years, maybe 7 years, 8 years, based upon how big your mainframe environment and assets are. So in order to wait till that time, so customers in the due course, customers are adopting some of the patterns that we are seeing in the augmentation side. For example, data and analytics. Customers start augmenting their data on the day one onto AWS environment and start performing data analytics on top of that. Or they build new business on top of that data because it's pretty much golden copy that you have on AWS environment. Build some new channels, or even they sometimes route the existing traffic, read-only traffic that is going onto the mainframe to AWS so that they can significantly save read-only operations cost, the MIPS cost for the read-only actions on the mainframe for databases such as VXAMPS or like DB2s, IMSDB, so on. Sometimes customers also adopt AWS in order to achieve quick returns by offloading their development and test workloads by leveraging hardware emulation pattern. And last but not least, customers also leverage various kind of AWS storage services to archive and back up their historical data. So with this, we are going to get into a dive deep session or like a dive deep demo onto one of the short-term migration pattern called replatforming onto AWS using emulation route. So let's look at the demo. And even before going to the demo, I would like to provide some insights about what exactly this refactoring onto AWS means. On the left-hand side, you could typically see your mainframe environment, where you have all the components of your mainframe, starting with your hardware, operating system, middleware layer, and your application source code, which all together are supporting your business functions. And once you migrate your mainframe workloads onto AWS using replatforming approach, your underlying hardware is going to be replaced with AWS infrastructure. And on top of that, you are going to run your operating system, Linux operating system or Windows operating system. And then you are going to have your middleware emulator software. On top of that, you are going to have your application code, utilities, and data formats pretty much as it is. Most of the times, your code base or your entire assets are going to remain same until unless there are some exceptional scenarios in case like if you are running some assembler on mainframe, some of the emulation software doesn't support assembler. So you may have to treat them or you have to transform them to a supported language by the emulator such as PL1, COBOL, or C, like that. And utilities, pretty much like you are going to have various utilities on the mainframe like a sort or IceGener and various things. So you are going to replace those kind of utilities with the equivalent utilities on the emulation environment. Your data formats pretty much remains the same. If you are using virtual storage access methods, VXAMPS, then they are going to remain as it is. Or if you are using any relational database, they can still remain as it is a relational database. So all these things, once they are migrated onto AWS, your business functions remains as it is. There is no change to your business functions. Everything supports as it is with a similar technology stack pretty much. And if you look at a different lens, here, the right side picture of this slide, you have your legacy mainframe hardware, which is residing in your corporate data center. You have your technology stack, COBOL, PL1, JCL, assembler, and all that. You have transaction managers like a CACS, IMSDC. You have batch subsystems, database files, and everything, every other components. Once you recompile and generate the binaries, your COBOL is going to still remain as a COBOL. PL1, everything remains as it is. JCL and Rex, everything as it is. All these things are going to be running on top of a virtual machine on AWS environment called EC2. And you still have flexibility of leveraging some of the AWS services. For example, you can tap onto various security services that you have in AWS ecosystems. You can leverage some of the monitoring services. You can also leverage some of the AWS purpose-built databases here in order to migrate your data onto AWS. So this is a high-level overview of what a middleware emulation means, or like refactoring your workloads onto AWS. So with this, we will switch our gears onto the demo. So before going on to the demo, I just want to give you a overview. What is that we are going to cover in the demo? So this is our typical flow of the demo. So I have a mainframe. I'm going to show you a sample application that's running on the mainframe, which we are going to replatform onto AWS using one of the emulation software provided by our mainframe migration competency partner named Micro Focus. I have a workload running on the mainframe, port the entire inventory onto the EC2 instance running on AWS, which has all the Micro Focus related softwares. So we are going to first see the Enterprise Analyzer. This is a software provided by the Micro Focus. It analyzes your entire inventory and give you the baseline application code. And this is the baseline code which you are going to take and then generate the binaries out of it by using another software called Enterprise Developer. And once the binaries are generated, you are going to deploy all those binaries onto a runtime environment of the Micro Focus software called Enterprise Server. So once your application is deployed, everything is up running. And for this demo, what we are going to do, we are going to replace the VJM files with Aurora database. So if you see the source environment, I have a COBOL, assembler, JCL, BMS, and VJAMs. COBOL will go as it is onto AWS. So Micro Focus Enterprise Server doesn't have runtime environment for the assembler. So we have converted those programs to COBOL. JCL will remain as it is JCL. BMS maps are going to remain as BMS. And VJAMs we are replacing with Aurora PostgreSQL. The purpose of replacing VJAMs with Aurora PostgreSQL is VJAMs are a single point of failure. So the purpose of choosing Aurora database is Aurora database is highly available and scalable, which offers 99.99% of the availability by replicating 6 different copies across 3 different availability zones. If we look at the cost standpoint, Aurora database is just 1/10 of the cost of the commercial database, which also delivers 3x times of higher throughput when you compare it with regular PostgreSQL database. So that's the reason we have chosen Aurora Postgres database here. And once the Aurora Postgres database has been created, we are going to migrate the entire VJM database, entire VJM data files onto Aurora Postgres. And then we are going to delete all those VJM files from the Micro Focus environment. And your application is going to access the data from the Aurora database. Sorry. The Micro Focus had designed a new feature called Micro Focus Database File Handler. This helps seamlessly to connect with Aurora Postgres database, having your applications running on top of Micro Focus emulator on EC2 instance. So let's look at the demo. So before going there, I want to show you the current application that's running on the mainframe. So I have a mainframe environment here. So I have a working applications online CSAs. It also does have batch. So I'm going to migrate this entire application now onto AWS environment. So I'm just going to log in to show you some of the features of this application. And this is the main screen. I mean like a main menu. You have various business functions here. So I just tap into display account balances where I can see all the accounts corresponding to the specific customer. So I have all these accounts and maybe I can just go into multiple transactions. So there are multiple transactions for each of these accounts. So I will just go into one of these accounts and see, okay, it says 35 transactions. So then I can just navigate across all the transactions just by pressing PF7 and PF8 logic, and I can even go back. So it has quite a few business functions. Maybe like we can see it has quite a few business functions. So we can see how these functions are going to exactly work as it is once you migrate it onto AWS. So I also have the source code for this entire application that's in my TSO environment. I have these data sets where I have all the assembler programs in one data set here. So I have a couple of programs which are completely assembler based. And I do have BMS maps. Likewise, I also have COBOL programs associated to this application. It has both batch and online, not just the batch, and also corresponding copybooks. Same way, I also extracted all your VJM files data into the flat files. So I have all the data here. So what I have done is I have imported all these assets onto Micro Focus Enterprise environment. So let me log into the EC2 instance where I have all the softwares. So this is my EC2 instance where I have all the required softwares. Like I have Enterprise Analyzer that we had seen here, the first software. I do also have Enterprise Developer, the second software that is required for us to do the lab or demo. And I also do have the third software like Enterprise Server. So I'm going to start with my Enterprise Analyzer, where I'm going to asset my entire inventory of the application, baseline the application inventory. For that, I'm going to launch the Enterprise Analyzer. Okay. Yeah, so it is asking me to create a new workspace. So I'm just going to create a new workspace and I will give some user-friendly name here. Click next. I'm going to provide the location of the source code here. So all my source code is residing under a workshops folder, which I have already ported from the mainframe. So I have all my application code that we had seen on the ZOS environment. I also have the data files that we had seen, the VGM data files, repro to the flat files. I have that. And also, yeah, we will come to that next folders later. So I'm going to select the ZOS applications and then just click next and go ahead and build it. This is going to take a minute or so to build the workspace. So your workspace had been created. All the assets that we had provided had been imported onto the Micro Focus Enterprise Analyzer. So this gives you a glimpse of what exactly we have imported. So it says like you have 67 copybook files and 42 COBOL programs, 2 assembler programs, and around 12, not around like 12 BMS files and few other stuff. So what I'm going to do, I'm going to first assess this entire inventory, which means I'm going to verify all the components. So this process, the verification process, assess your entire inventory, generates the metadata, and stores that entire metadata into the data model that is going to be provided by the Micro Focus Enterprise Analyzer. So this metadata is going to be used while we are generating the reports. So the verification process is going to identify the dependencies between each and every component, what kind of obsolete components are there, what is the complexity of each and every program, what is the dead code of the program, and so on. So let me click on verify. And the verification process had just started. So it's going to take a minute so that the entire verification process had been completed. So it gives us the status about each and every component it has assessed. So I see some warnings here. So let me just filter out whatever we have in the warnings. Okay. Before going to the warnings, we can generate some reports which gives us some inferences. So for example, if we go to the reports table and click on reference reports, I can see like what are the obsolete components in this entire inventory, which means there is a program, but neither a job nor a transaction is being invoking that specific program. So which means it's a obsolete or it's a dead component. So if I click on unreferenced report, it's going to generate a report for me, and also like it is going to tell us like what are the obsolete components. So don't consider these programs are obsolete. So there is a specific reason why these programs are coming in this list. But if you look at this ZBank ZKEXT1 and ZBank ZKPRT1, these are a couple of programs which I have in my repository. Over here, I have a couple of these programs. So ZBank ZKPRT, ZBank ZEXT1. So this clearly tells us, this report clearly tells us, hey, these are the obsolete components. So if I have to migrate and if I want to baseline my inventory for the migration, then I no need to consider these two programs because these are obsolete components. Knock off this from your scope and just focus only on the components which are really required for your applications to run. These are obsolete. So likewise, we can generate various kind of reports. So maybe if we can look at So for example, if you want to see the missing objects, so if I look at this specific BBank 10P report, this gives us insights what was the problem with this specific program, why it was unable to assess or analyze it. So this says like it was unable to open a copybook called CBank D01, which means somewhere in this program, BBank 10P, yeah, so you can see here like BBank 10P is referring to the copybook CBank D01, and this component we haven't provided in the entire inventory that we are given to the enterprise analyzer. So we can come to the copybook folders and we can see CBank D01 is missing here. So this gives us insights like what components are missing, what are the obsolete components. So let's go ahead and add this specific component here and re-verify those two COBOL programs. Add files. For the sake of this lab, I had copied the missing components into ZOS, so CBank D01P, and it clearly tells one file had been registered. So I will just go ahead and clear the log so we will have clear visibility. Okay, now this BBank 10P and DBank 10P, I will go ahead and re-verify once again. And this time the enterprise analyzer should find the copybook which it was missing earlier and should clear the verification process. So you could see the process, the verification process was successful even to these two programs as well. So this way we can identify the missing objects, we can also identify the obsolete components, and also we can generate some smart things from this tool. So for example, if I want to know what is the dependency between each and every program to the corresponding files or tables, then I can generate the CRUD report. So the CRUD report has been generated and you can double click on this. So this CRUD report gives us insights like, okay, hey, I have these set of programs and each program is having different kind of database operations or file operations. So for example, DBank01P is accessing bank customer file. It's only reading the data from it. Likewise, DBank02P is reading or accessing bank customer file, which is performing both update and read operations. So once we have this data, then in case if we are planning to do a wave-wise migration, then we can plan accordingly in such a way that the data dependencies between different waves can be managed via data replication process. So this is very helpful report in order to identify the dependencies between databases and programs. Likewise, there are numerous reports this tool is going to be generated. And for example, like now that I have imported and assessed everything, I need to really understand what is that the enterprise server, the runtime environment supports for me. Could there be any anomalies which it doesn't support? So that those details can be found in the portability assessment report. So let me generate the portability assessment report. So your portability assessment report had been generated. So let's open this and see portability insights under the assessment report. So this gives us a clear indication what is that which Micro Focus Enterprise Server can be supported and what it cannot. So that way we can plan our efforts for the migration. So if you see the conversion requirements, so this clearly tells us, okay, hey, I have a couple of assembler programs which are being referred by these programs, and these assembler programs cannot be supported by the enterprise server. So you need to give a proper treatment for them, either converting them to COBOL or PL1 or whatever the interest of choice you have. So likewise, the assessment report is going to give us a good insights, what that can be supported and what is not that supported, and what kind of treatment plan you need to consider for the unsupported components. Coming back to the enterprise analyzer, last but not least, I will just run through another reports. Maybe like I can generate various kind of diagrams as well, the flow diagrams between each and every component of the entire application. So for example, if I want to understand the job flow, then I can just build a diagram for that. And this gives us some level of insights. For example, like I have a job TRN report, transaction report, and this is going to invoke a program called ZBank EXT1, and it's further calling it's further referring to another file. So it's basically this program is writing records, insert into file. So that's the operation it's been performing on this file. Likewise, the same job is also invoking another program called zbank prt1 print1. So this is extracting the data and this is printing onto the report. So it generates one output and also it reads from this file, and also it has a system program called sort. So basically we can use this diagrammer facility to generate various kind of diagrams for the entire application dependency. So with this, we are done of looking at the enterprise analyzer, where we had identified all the components, where we had identified the missing components. We also eliminated the obsolete components. So I have a baseline inventory now. So the next step is I'm going to take those to my enterprise developer and compile and generate the binaries. So before doing that, we had already seen the assessment report showed us there are a couple of programs which are not supported by the enterprise server. So what we did is we had converted those programs to COBOL already. So UDATE-CNV, if you open it, this was converted to COBOL, and earlier we had the similar program in assembler, UDATE-CNV. So we did a conversion of this assembler program to the COBOL. So now that I have all the programs which are required for me to compile and generate binaries in Enterprise Developer. So I have Enterprise Developer here, and once I double click it, the software has been opened. And since we are dealing with the COBOL project, I'm choosing COBOL Perspective mode. I'm just going to disable the build automatically feature, and I will import all the assets that were baseline from the enterprise analyzer. So before that, I'm going to create a project, new mainframe COBOL projects. I'm going to create a project, give a project name, and click on finish. So now that the project has been created, I don't have any components at this point of time. So I need to import all the assets that were baseline from the enterprise analyzer. So click on import, select import, go to the location where we have the baseline inventory. So C, workshops, application. So this is where we have entered the baseline inventory. Now, when I am compiling all these components, I no need to have assembler, because assembler was already been converted to COBOL, and those COBOL programs are available in the COBOL folder. I'm not going to compile CACS system definitions. Okay. And also I no need to compile the JCLs, right? Click on finish. Now I have all the components here, all my COBOL programs and corresponding copybooks and rest of the stuff. I'm going to compile them now, but before compiling, I need to make some changes to the compiler settings. So I'm going to the properties, micro focus. So these are the basic COBOL compiler settings that had been provided. And there are quite a few directives that are available, and I'm going to add few more additional directives that are required for my application to run. So I'm going to add these additional directives. Okay. And then since I have both CACS and batch programs here, I'm going to enable the Kix preprocessor. So I'm enabling the Kix preprocessor, and there are some batch programs, but I'm enabling for all, irrespective of the batch or online, but we are going to disable Kix preprocessor option once we are done with this setup. Okay, and I'm going to configure the dependency part here, and that's it. So there are some batch programs as we talked, and I'm going to disable the Kix preprocessor for those components. So for example, I have dbank 51 is a batch program, 52 is a batch program, UDATE-CNV is a batch program, zbank ext1, zbank prt1, these are the batch programs. So I don't want to enable the Kix preprocessors because there are no Kix instructions there. I'm disabling it, apply, compile. Now that the compiler settings are done, I'm going to start compiling. So first I'm going to compile the BMS maps because the symbolic maps or the symbolic copybooks of these maps are referred by my COBOL program. So once I compile these, the symbolic maps are going to be generated so that the COBOL programs can be compiled successfully by accessing those symbolic maps. So first I'm going to compile the BMS components. Okay, compile. So if you see all your components like all your BMS map sets were compiled successfully and the associated symbolic maps were also being generated. So this is a symbolic copybook which had been generated and this is being referred by my COBOL online programs. And also it had created the corresponding binaries. So these are the binaries associated to the screens, the BMS maps. Now I'm going to compile all the COBOL programs. Compile. Okay, so the compilation process had been completed and the build was successful. Most of the time, like majority of the times, the compilation for your COBOL programs will be successful in the first attempt itself because that's the way Micro Focus compilers are matured to compile all your programs. So now if you look at this folder, like where all the binaries are residing, so I have all the DLLs for all the COBOL programs, right? So what I'm going to do, now I'm going to invoke the third, now I'm going to deploy all these binaries which are generated by the enterprise developer, this one into enterprise server. So I'm going to copy all the binaries from this uh, location to the enterprise server wherever it's been deployed. So for that, I'm going to launch Micro Focus command prompt and just invoke a couple of commands. So where it had copied all the binaries from enterprise developer location to enterprise server location. So now we have copied all the binaries. There are two more things that we need to do. So if you look at this application, I also does have the kick system definitions, right? So I need to even upload all these kick system definitions onto the Micro Focus enterprise server. So if you see the enterprise server now, so this is the enterprise server and I'm going to the associated server that we have now for this application called ESLab. And if I click on CACS, I don't see anything here. There are no resources. And also this server is currently in a stopped state. So first I'm going to upload all the resources under CACS and then we are going to do the data migration from flat files to VZAM files. For that, I'm going to run a couple of more commands. So I'm going to, I have just invoked cas rdt up command, which will take all the CSDs, all the kick system definitions from the bank demo G, and it will upload to the Micro Focus enterprise environment. I can go and see whether all my CSCS resources have been added to the Kix environment or not. So I have a group. The group name is ESLabG. And if you click on the drop-down, you could see all the associated resources that we have in the Kix system definitions are being cataloged under the Micro Focus Enterprise Server environment. So I have all my files and the file name and the physical location. I also does have all the programs and so on. So now that all the CACS resources were being defined, the next step is I'm going to migrate the data. So currently, if you look at the catalog, I don't have anything. It's a blank, the catalog is blank. I don't have any VZAM files, neither a flat file. So we had imported all the VZAM files data from mainframe onto Micro Focus enterprise servers, whatever the EC2 instance that we are running now. But these files are just located at a physical location under this specific path, but we need to catalog them onto Micro Focus enterprise server. So for that, what I'm going to do, first I'm going to copy these files to ES lab location, maybe under data, so data files. And then I'm going to catalog those files to the enterprise server. So for that, I'm going to run a couple of commands. Okay, so the files were being copied. So the files are in ES lab folder now, which is the desired folder where I want all the data files to be. And then I'm going to run a job bank dvzam.jcl. So I also have the JCL, which I've exported from the ZOS environment. And this JCL does have all the steps where it will catalog all these VZAM files, flat files, and also it will create the various VZAM clusters, and it will repro the data from these flat files to the VZAM. So I have all the steps over here. So I'm going to run this job. So for that, I'm going to execute a carsub command, press enter. This job is going to be submitted to the jest now. So if you come to the enterprise server console, you can go to the spool and you can see the job. So job has quite a few steps here. So it has multiple steps. All these steps are going to catalog the flat files, create the VZAM clusters, create the paths, create alternate indexes, and then repro the data. So now that you have your job ran successfully with condition code 0, which means your data also had been migrated. Now let's go ahead and list our catalog here. So you could see all the files. You can see all the VZAMs, or you can see all the physical sequential files and all the things here. So if you just look at the attributes of this VZAM file, currently you can browse the data, and you can maybe you can even display the attributes. So currently the physical location for this VZAM file is CES lab data and so on, so on. So that's where this location is, ES lab data. So this is the location where this enterprise server is pointing towards. So CES lab data, and the corresponding VZAM file. So all the physical files are currently residing on the local drive of our EC2 instance. So let me give a try of testing this application now. So I'm going to start an emulator here, session 3270 terminal. And let me give a try running this application. Okay. Okay, so the transaction is bank, and I could see the same application, whatever we had seen beginning of the session that was running on the ZOS is now running on AWS on top of an emulation software provided by the Micro Focus. So I'm going to just log in and see what are the functions that we had seen earlier. So all the functions that we had seen carry forwarded here. So I will just go ahead and display account balances. I can see some transactions for all these accounts. I'm just going to browse one of the account and see there's 16 transactions. So I can just navigate back and forth to see all the list of transactions. So likewise, I also do have accounts, fund transfer between the accounts. Maybe I can do some fund transfer between the accounts and the same function, whatever the business function that we had seen on ZOS environment, we are seeing the same business function even on AWS on top of an emulation software. So this is good. Now you have an application up running on Micro Focus with all your files cataloged, and the location of all the physical location of all the files is on your C drive. But again, as we talked about, VZAMs are a single point of failure. So that's the reason we are going to migrate all these VZAMs data onto Aurora PostgreSQL database. So for that, what I'm going to do, I'm going to log into the AWS console, create an Aurora Postgres database. So now that I have logged into AWS Management Console, so before creating an Aurora database, I'm going to create a security groups in the EC2 instance. So security groups are the virtual firewalls which controls both inbound and outbound traffic to your resource on AWS. So for example, like in this scenario, I'm going to create a security groups for the Aurora database where it will allow only the traffic coming from the EC2 instance. So go to the EC2 instance, and under security groups, create new security group, and then just select which VPC where you want to create the security group. So my Aurora database and this EC2 instance where the emulation software is running will be on the same VPC. So I have selected the same VPC over here, a Micro Focus VPC, and I'm going to add an inbound rule. So since it's a PostgreSQL database, I'm going to select Postgres there, and also I'm going to select the corresponding security group where the incoming traffic is going to be acceptable. So add rule, create security group. So I had created the security group now. So now I will go to RDS and create Aurora PostgreSQL database. Okay, create database. I'm going to create a simple Aurora PostgreSQL database here. Select Aurora PostgreSQL database and select dev test, and I want to give some meaningful names to my database and all that. So I'm going to give MFLab, and I want to keep my passwords also very simple. I'm choosing the burstable class instance. I'm selecting the Micro Focus VPC here, and also I'm going to select the same security group that I have created earlier. Come to the additional configurations. I'm going to create an initial database here. Maybe I can create something again like a meaningful name. And I'm going to disable the enhanced monitoring feature, and then go ahead and click on create database. So this database is going to take a little while to create. So now that my Aurora database had been created, I'm going to take the endpoint and configure this endpoint with the ODBC connectivity. So I have a Micro Focus Enterprise server running where my application is currently pointing to the VZAM files. I have already created Aurora PostgreSQL database. In between of these two, I'm going to establish a ODBC connectivity so that my Micro Focus Enterprise server can directly read the data from, process the data from the Aurora PostgreSQL database. So let me go back to the EC2 instance. So I have ODBC sources here. So like already we had created this MFLabDB initial database that we had created when we are creating the RDS Aurora instance. So I'm going to just provide the endpoint over here and copy it, and I'm just going to provide the endpoint here and test it whether it's connected or not. So the initial database that was created when I'm creating the Aurora database is connected successfully. Save it. Now I need to create another data store for my VZAMs to store the data. So for that, I have this data store, and I'm going to provide the same endpoint here. I'm not going to test it because I haven't created this yet. We are going to create this now because the Micro Focus database file handler is going to use this specific data store to store the VZAM files. Save it. Let's not do any testing right now. What I'm going to do, I'm going to run a couple of more commands for me to create the data store. This is going to create this specific command had created me. Okay, now that after running these two commands, I was able to create the data store. So if I go back to my ODBC connectivity here and test this specific source, which is mapped to the data store, it should be successful. Test, and the connection was successful, which means now my Micro Focus Enterprise server can seamlessly reach out to the Aurora database and process the application as normal. Save. Okay. So till now, what we did was we had created Aurora PostgreSQL database. We had set up the ODBC connectivity. Now we need to migrate this VZAM's data onto Aurora PostgreSQL database. For that, I'm going to run a couple of more additional commands. Okay, before doing that, I just want to show something like currently all your data files, the physical location of all your files are here in the C drive, and there is a catalog file. This is being maintained by Micro Focus Enterprise Server. So this will have the physical location for each and every logical file, and this catalog file is going to be referred by Micro Focus while processing any jobs or accessing any data. So we need to change the endpoint of all these logical files to Aurora database. So for that, what I'm going to do, I'm going to run a couple of commands here. Okay, now, so after running that command, I would be expecting the .data file, the catalog.dat file is going to be changed with a new endpoint for each and every file. So if I just open it once again, so if you see, the logical files are having the same names. I mean, like they are as it is, and the physical location for each and every logical file is being mapped to Aurora PostgreSQL database. So till now, what we did, we had created Aurora PostgreSQL database. We had established a ODBC connectivity. We also had changed the endpoints for each and every logical file to Aurora PostgreSQL database. Now that we have everything, we just need to migrate the data from vSAM files to Aurora PostgreSQL database. So for that, I'm going to just run one small command over here. So this is taking each and every file and it's uploading all the records onto Aurora PostgreSQL database. Okay. Now, if I come back to my enterprise server here, if I go to the catalog, ESLab, just catalog and list it, I should be able to see the endpoint, the physical location for each and every file would be Aurora database endpoint. So earlier we had C colon ESLab data and so on so, but now it's been replaced with endpoint of Aurora PostgreSQL database. Now I'm going to just reconnect and test this application. And your application is functioning as normal as it was accessing the vSAM files. Okay, and or even you can perform the same business function like transferring between the accounts, and it does exactly the same way as it was performing by referring to the vSAM files. So the contact information had been updated. So this way, your vSAMs had been replaced with Aurora PostgreSQL database, which gives you high availability and high scalability. As a last step, right? So let's go ahead and delete all these vSAM, all the files that we have in the data folder. Delete, and you don't have any files now. So I'm still expecting the application is going to run as it is, as normal. So let me log in once again. Okay. So we just did one transaction, like we've transferred funds between the accounts, $9.99. You could even see that as well here. Just did a while ago. This was done pointing to the Aurora PostgreSQL database, and this was done when we did had vSAMs as a endpoint. Again, both are two different accounts that we did earlier and now. Likewise, your application is now highly available and scalable with Aurora PostgreSQL database. So this concludes end of our session. And in case if you have any of your mainframe workloads needs to be migrated onto AWS, so feel free to reach us it's not just for the pattern that you had seen now, a demo, replatforming to AWS. So we can help you with any of the mainframe migration patterns that you had seen in the presentation. So I really appreciate your time for today. Thank you very much.